I would like to welcome our next speaker, which is Annerose Hüttl. And I'm happy to announce you, Annerose Hüttl holds a diploma on chemical engineering. After a long career in the automotive supply industry, she joined Kunststoffzentrum in Leipzig in 2008. As research associate, she is specialized on lightweight thermoplastic processing technologies. Here she is familiar with the special requirements of biopolymers. And her credo is, let's make bioplastics lighter and stronger through bionic structures. A warm welcome to Annerose Hüttl from the Kunststoffzentrum in Leipzig with a lecture on the topic PBS as a monomaterial for sandwich components. Welcome.
Thank you very much for your warm introduction and very welcome to my talk about our special lightweight parts manufactured by a foam injection molding process. What's the outline of my talk? A short introduction of me and my work, something about bionic construction principles, how we use the sandwich effect, our special manufacturing process, the two-component foam injection molding process, a very long name, our experiments and results with the material PBS, some possible industrial applications, and our plans for the future. My name is Annerose Hüttl, and I'm working at Kunststoffzentrum in Leipzig, a town nearby, as a scientific associate. My main topics are plastic recycling in general, foam injection molding, industrial services, and vocational training. The Kunststoffzentrum in Leipzig is a non-profit, self-financed research institution, and we can do the entire value chain of plastic processing. I start with a little introduction in bionic construction. The first example you see in the figure above is the backside of Victoria regia, the tropic water lily. The ribs on its backside provide stability and stiffness for the plant, and the little cells inside the ribs are filled with air and provide buoyancy. This construction principle you can transfer on that plastic part below. It's a widely used construction principle in the plastic industry, that typical cross-rib structure. My other example is that insect shell. It's very important for the insect that the shell is very low in weight, so that it can fly at all. Its outer layers are made of stiff and rigid material, and the inside cells are very light, so that its overall weight can be very low. We transfer that into that foam injection molded part, and that two that two little examples have in common that they both use the advantage of the so-called sandwich effect. In the figure above, you see the explanation of the sandwich effect. Under bending load, the outer layers take the main load. And the more you come near the neutral axis, in the middle of the cross-section, the load decreases continuously. That means that you can save weight and have, in case of bending force, the same properties. Ideal is an integral, so-called integral foam structure, as you see it in the middle, with a compact skin layer and decreasingly becoming larger bubbles to the neutral axis. We also use the advantage of the sandwich effect for lightweight in our PBS part in the figure below. And perhaps you ask yourself the question how these parts are manufactured. The foam injection molding can be done in many ways. The easiest way is just to add a blowing agent and dose it together with the resin in the hopper of the injection molding machine. That's the cheapest way because you can use it on any standard injection molding machine. For direct physical gassing into the melt, you need a special gassing unit, and are several suppliers on the market. Mucell process of Drechsel is the most known process. The foam injection molding process has a severe disadvantage. You see it at the photo below, that so-called foam streaks are a surface defect, and the surface is looking very unattractive, a weak surface quality. The cause for that you see above. The bubbles burst at the melt front, and that causes that streaks. That's the reason why most conventional applications in the past are in the non-visible area, where you cannot see it. To solve this problem, some newer developments are available. Mostly known is the variothermal temperature control. And another possibility is the two-component sandwich injection molding I want to introduce to you on the next chart. Here you see our two-component injection molding machine in our technical center. And the two kinds of melts are provided by two plasticizing units. The first component injects the compact skin PBS, and just after a very short time, the horizontal plasticizing unit injects the PBS foam. In the enlargement, you see the structure of the sandwich in the intermediate plate that is mounted between the plasticizing unit and the tool. That intermediate plate is important to control the correct skin core structure. This enlargement shows the special foam plasticizing unit. Here you see the gas injector and the special screw design. The mixing area of the screw is very important to get a homogeneous gas melt mixture. And now I come to the experiments with PBS. At first, we just manufactured a plate because we wanted to do some mechanical and other tests on it. It consists of a compact skin PBS layer. For better visibility, we colored it with a color master badge, and its carrier is also PBS. And a neutral colored core layer of foam PBS. With that, we achieved a weight reduction of 22% compared to the compact plate. And total plate density of 0.98 gram per cube centimeter. Now we tested two different grades of PBS, and the main difference is viscosity. With a lower melt flow rate grade BioPolymer A22 of Exypnos, we achieved a homogeneous foam structure with spherical or mechanical more favorable bubble shape. The reason for that lies in that higher melt stability of A22. Here are some possible industrial applications. The process is favorable for larger parts, for parts who have to bear load, and where a reduction in moving passes is for advantage. For example, that rotor or fan, a gearing wheel, a step, for example, for moving systems, carriers, or supports like a carrier for robot and arm tooling. What are we intending to do next in our technical center? We intend to manufacture a little bit more complicated geometry, that a lower part of a lightweight case. Let's summarize. My take-home messages for you are: the two-component sandwich injection molding can be a way to process PBS into technical applications. The lightweight bionic design leads to material and cost savings. And my motto is, let's make PBS lighter and stronger by bionic construction. Thank you for your attention, and now I'm looking forward to your questions.
Many thanks to Annerose Hüttl from Kunststoffzentrum in Leipzig. Thank you very much. So, you are invited to ask a question, if you have a question.
Even 2 or 3.
No question so far. Oh, there is one question. Great. Okay. Patrick. Yes.
So normally nucleation agents are used for forming to get a microcellular structure or something like this. So do you plan to work on this as well?
Nucleating agents are used for our foamed core, and it's very advantageous to get foam structure that is homogeneous. We tried out several systems from torque to active nucleation agents like chemical blowing agent, a mixture between physical and chemical blowing agent gets best results in homogeneous foam structure.
Okay, good. Thank you.
Thank you.
Thank you.
Are there further questions of the audience? If not, I have a question to you. So talking about forming is always weight reduction, but have you also measured the comparison between the formed part and the rigid part? How is the difference? Is it similar in top load or in bending strength or something like that? Have you also done some technical measurements on that? Mechanical measurements?
Yes, but it's not inside my presentation today. I could send it to you.
But can you reveal to the audience, is it similar, is it far away, or you still need to optimize on the PBS, or is it a secret, which is?
Which kind of load do you mean? Do you mean tensile? Do you mean bending or torsion load?
Bending load.
Bending load. For bending load, it's dependent if the form structure is integral or homogeneous. If it is integral form with compact skin layer, it's very near the bending strength of a compact plate. Very near or equal. And if it's homogeneous, you have larger bubbles at the outside layer, it's lower.
Yeah, for sure. But sounds promising for technical parts at least. So seems to be that you're moving the Rubio part also project also to technical parts.
Yes,
that's more
that was our intention.
Very nice. Thank you very much for the questions, and thank you very much for your lecture. And I'm pretty sure somebody has some more questions now in the coffee break. You're still available, right?
Thank you very much, Annerose Hüttl aus Leipzig.